All right, today we're going to talk about transformations. And they call it lines and motions, but basically this is about moving a graph around horizontally or vertically. Could be any graph, not just a line, I guess. So a translation is the movement. Oh my goodness. The movement horizontally, meaning in the x direction, or vertically, meaning in the y direction, of a graph. Bless you.
Bless you.
And the image is the new graph after a translation. For some reason I call it the image of a line is the slope-intercept form. This is the one that most people use frequently, mx plus b. And this is really useful because you can see right away what the slope of that line is, and you can see the y-intercept of that line. So as we're doing lines, this is the one that a lot of people like to use in our calculator. When we're doing a regression line, there are two different ones dedicated to just this thing. Sometimes they say ax plus b, sometimes they say a plus bx. The point slope form of the line is actually, in calculus, the most popular one. And it goes like this: y minus y1 equals m times x minus x1. And that's where your m is the slope, just like in the previous formula. And the x1 and the y1 are the point that they will give you. That's why they call it the point slope formula. So that was the second one that they talked about. And sometimes when you're graphing, a very popular one to use is something they call standard form. You'll learn this in pre-calculus. It goes like this: ax plus by equals c. Some books will say plus c equals 0. The a, the b, and the c are integers, meaning that they cannot be fractions or decimals. And the a is positive. And then the last thing is the slope, of course, that we use all the time with lines. And that's where we talk about it usually as an m. We don't have to, but in the previous two formulas, the intercept form and the point slope form, we used m for that. And that was where we took 2 points and went y2 minus y1 over x2 minus x1, where the x1, y1, and the x2, y2 were points. First point, second point. And so in case you don't remember, our order pairs are always x, y. And so when they talk about x1, y1, that means the first point that you're talking about. And x2, y2 is the second point. So now we're going to actually do some of these translations. I'm going to do some stuff that's off of our notes, and then we're going to do the Joachim super secret notes. So I don't want you to share those with anybody else. So there are two kinds of translations that we talked about in the very beginning part of the notes. One was a horizontal translation. If you're working with horizontal translations, that's dealing with stuff that comes inside of a parentheses. So that h, you'll notice, is inside a parentheses. And that's a movement horizontally. So this is the left and right movement when you see something inside of a grouping symbol or a parentheses. And then the other kind of movement is the vertical movement, and that comes on the outside of a parentheses. And that's the up and down movement. And I'm going to show you how this works in the super secret notes in addition to our regular notes. So stuff that occurs inside a parentheses or a grouping symbol, like a square root maybe even, would be a horizontal movement. And then stuff that's on the outside is a vertical movement. And that'll make a lot more sense as we do a couple of examples. All right, let's look at some examples. So on this next page, they talk about a line. And they say write an equation if you move this line up 3 units. So here's what happens. You have the original line. The original line is y equals 4 plus 2x. If you want to do something vertically, you don't do it inside of a grouping symbol, you do it on the outside, or in other words, it only affects the y value. So as I look at this, to move it vertically, or translate it up 3 units, I would go up 3. So this is the up 3 thing. Notice how it's not on the inside of a parentheses anywhere. If I'm going to simplify this, of course I should always simplify if I can. So now my new equation, if I wrote it in its simplified format, would be y equals, and then the 3 and the 4 together, of course, is 7 plus 2x. So this would be my ending equation. But just to kind of see what happened with the up 3, I put the plus 3 on the end there so you can see it. As opposed to, if I want to translate something to the left 3, here's what happens. Y equals 4 plus 2 times, and now if I want to move it left and right, the x stuff is stuff along the horizontal axis. So if I change what's happening on the horizontal axis, or left and right, that means I'm changing the x thing. And the way that that works, which is a little bit strange, is you do the opposite of what you think would be happening. So normally I'd go like plus 3 to move something up, and you would think that if you're moving left, you'd want to go minus 3, but it's actually the reverse. It's x plus 3. And it's on the inside of a parentheses, because that's the horizontal movement. And the reason that it's the opposite of what you think it would be is because when you're moving something to the left, what you want to do is you want to do the negative thing, but look at the negative 3. So this left 3 units right here, if I'm looking at this, is this stuff right here, because if I think about what makes the parentheses 0, it's a negative 3. And that's why I know it's moving left 3. If I rewrite this in its simplified form, what I see is that this 2 is being multiplied by the 3. So 2 times 3 is 6, plus 4 more, that's a total of 10. So now I have y equals 10, and then plus the 2 times zx. Kind of a weird deal. Daniel, this time I want to move down 7 units. So that's not going to happen on the inside of a parentheses. So as I start out, I have y equals the 4 plus the 2x, like I have in the past. But now I want to move it down. So don't put it in a parentheses, just go down 3, and it's just like you think it would be. It's down 3. That's what I meant. Sorry. 7, thank you. That's awesome. And then if I rewrite it in its simplified form, I have a 4 and a minus 7. So really I have negative 3. And I still have my slope of 2x. Now if you were to graph these lines, you would see how it's been moved either up or down the line. We're not going to do that on our calculator. You can do that some other time. In letter D, they try to get tricky with us. They try to say, oh, hey, what are you going to do? You're going to go up 1 and right 7 both. So as I write this equation down, I know I have the y equals the 4. And then since they told me that I'm going to go right 7, I know that I have to go x minus 7, which was the comment that Daniel was making earlier. And then I also want to go up 1, so I put down plus 1 at the end. And this has moved my graph right 7 and up 1. And of course I can always simplify it. So I have the 2 on the outside of the parentheses being multiplied by the negative 7. That's a total of negative 14. Negative 14 and 4 is negative 10. Negative 10 plus 1 is negative 9. So I have y equals negative 9, and I still have that 2x because of the 2 times the x. You could also write it as 2x minus 9 if you want to. I don't really care. That's fine. Crud. So in this particular example, what we noticed, I'm going to erase this and do it again because I didn't have it recorded, so sorry. Don't worry, I'll have the same thing. In this particular example, we see the W in the purple, and then we see the instructions down below. And in these instructions, since there's something on the inside of the parentheses, that means horizontally. So I know that I'm supposed to move left 2, and then outside is a minus 4. That means I move down 4 again. And as I redraw this, I just take the key points and move those points. So left 2, down 4. Here's a new point. Left 2, down 4. Hope I got that right. Left 2, down 4. Left 2, down 4. And left 2, down 4. And redraw my W. And basically, the W has been moved to the left 2 and down 4. Okay, so here we have this absolute value graph, the basic one in blue, y equals absolute value of x. And in the red, you can see it's moved 2. So this 2 to the right, that is. So this looks like the following. Absolute value of x minus 2. Whereas, if I were to draw the following graph in brown, this graph has moved up 1. Look at the difference. Notice how the number that's affecting the graph is on the outside of the symbols in the brown, but in the red, it was inside. Inside, outside. Inside stuff is the horizontal movement, outside stuff is the vertical movement. And so if I were moving something down, like for example here, this graph would be y equals the absolute value of x, and then on the outside, minus 3. And if I move something to the left, like this, this is y equals the absolute value of x plus 2. And notice how the 2 thing is on the inside, because it's horizontal movement. And then, of course, I could do a combo if I wanted to. So, for example, I could maybe put something over here. And I look at where the vertex is in the light blue graph, and I notice that it's moved 3 to the right and 1 down. So that would be y equals the absolute value of x minus 3, because remember it's the opposite on the inside. And then it went down 1, so it's minus 1 on the outside. And these graphs kind of show you a picture of what's going on with a graph based on what's happening on the inside of a grouping symbol, like a parentheses or an absolute value or a square root, or on the outside. And I kind of like that because for me, I'm very visual, so that really helps me, and hopefully that helps you as well.